Geometry Unit 14, Section 6, Equations of Circles. So we've been working with circles for a while now, doing arcs and angles and segment lengths formed by chords, diameters, secants, radii, tangents, things like that. But now we're going to look at, in the next couple of lessons, circles in a coordinate way. So what is the coordinate equation of a circle? We know the, equation of a line, y equals mx plus b, and you should be familiar with the equation of a quadratic or a parabola, like y equals x squared plus 5x minus 6, something like that. Um, and probably some other equations you did in Algebra 1, but you've never seen the equation of a circle before on a coordinate plane. And before I get into what that equation is, let's talk about what circles really are. So the figure shows the graph of circle O with several labeled points on the graph. We have A, B, C, D, and their coordinates labeled along. And the center of the circle is O. What do points A, B, C, D, along with every other point on the circle, have in common? Well, what a circle is a collection of points that are equidistant from a center point. So A, B, C, D, they are all the same distance away from the point O. And we can see that. What is that distance? Well, when it's something like a, horizontal line like OA is here, let me use my line tool. Go to a very thin line and actually draw some of these. So OA, that's a distance of 1, 2, 3, 4, 5. I could just count those boxes there, and I could see that that distance is 5. How about the distance of BO? Let's see if I connect that right there. Now let's use the Pythagorean theorem this time. Let's see. If I were to turn this into a triangle, it would be over 1, 2, 3, 4, down 3. So that's a 3, 4, and then Pythagorean theorem, 3 squared plus 4 squared. Let's see, that's 9 plus 16 is 25. Square root of 25 is also 5. So Pythagorean theorem works just well. How about OC? And you could probably guess it's going to be 5, but let's see. Let's do OC. Let's do this one in green. And this time, let me use the distance formula. We haven't seen the distance formula in a couple of chapters. The distance formula, if you remember, basically is the Pythagorean theorem. It is x minus x, x1 or x2 minus x1, doesn't really matter, squared, because it's squared. That's why it doesn't really matter, because if it comes out to be 5 or negative 5, it's going to both square to the same thing. Plus y2 minus y1. We tend to always do second minus first, though, just for consistency. The only time it really matters is certain problems like slope, a directed line segment, um, rotating point, things like that. For distance, it really doesn't matter. But anyways, there's your distance formula. And that's what we did here. Like when we counted boxes to 4 here, that's the equivalent of x2 minus x1. Okay, I took our x values of 4 and 5. The difference there is 4. 1 and 5, sorry. The difference there is 4. And then subtracting the y values, that's what we did here. There was, difference of 8 and 3. 8 and 5 is 3. But let's actually use this formula here for CO here. So the distance of CO. And so we subtract the x values. That would be 5 minus 8. 5 minus 8 squared plus 5 minus 9 squared. And let's see, 5 minus 8 is negative 3 squared, and 5 minus 9 is negative 4 squared, still in the square root. 3 squared is 9, 4 squared is 16, adds to 25. Again, this is all still in the square root, so the distance, again, square root of 25 is 5, so I get 5. Again, that's the same thing as, over 3 is subtracting the x values, 5 and 8, and up 4, subtracting the y values, 5 and 9, and getting 3, 4, 5. And again, we'll see the same thing for OD here is also 5. So all of these points have a distance of 5. So that's what a circle is. It's a collection of points all the same distance from a center. And just like a line is a collection of points that all satisfy a pattern, a slope, 2x minus 5. Take the x value, w at minus 5. Take the next x value, w at minus 5. That's what a line is. A circle is a collection of points that are equidistant from a center. This is what the equation of a circle looks like. X minus h squared plus y minus k squared equals r squared. where h and k are the coordinates of the center, and r is the length of the radius. Because that's really the two things you only really need to know, or the only two things you really can know about a circle on a coordinate plane is where is it? That's the coordinate of the center. And how big is it? That's your radius. So those are the two things that make a circle, where it is and how big the radius is. Just like a line, the two things you need to know are where it is, the y-intercept, and its slope. So slope and intercept, here we have center and radius. So does this look familiar? Well, it kind of does, because that's kind of what we have up here for the distance formula. The distance formula where, if I were to do the distance between hk and xy, but instead of d, let's call it r. So r equals, r is the distance here. That would be, I'd subtract the x values. That'd be, x minus h, or h minus x minus h squared, and then subtract the y values, y minus k squared. And so how is this the same thing? Well, instead of having this under a giant square root, you could square both sides, and that's what's going to give you this. Just like, instead of having d equals 25, we can have d squared equals 5 or something like that, well, this is actually, I'm sorry, d squared equals 25. Well, d equals 5. So anyways, here's our equation for a circle, and it's really pretty simple. You just need to know the center and radius and plug it into this. Well, what I've been trying to spend the last 7 minutes is explaining to you where this comes from. That it's simply all of the points are going to have the same distance. They're all going to have the same r squared. So every single one of these points is going to be 5 away from that point. So like this circle, for example, the equation of this circle would be x minus 5 squared. Because what are we doing? No matter what point we're on here, we have to subtract 5. It's going to be 5, how far is it from 5 on the x-axis? That's the distance from it to 5, is the x value minus 5. This was 1 minus 5 was a distance of 4. 8 minus 5, a distance of 3. 9 minus 5, a distance of 4. Plus y minus 5, just like all these points, it would be 1 minus 5, 8 minus 5, 8 minus 5, 9 minus 5, 9 minus 5, 2 minus 5, if we did the distance formulas. But instead of using 5, 5 for the center, we use x and y. But they're all that far away, and it's going to equal 25. Because it's not in the giant square root, so we set it equal to the radius squared, not the radius. And that's probably the biggest mistake you guys are going to make, is you're going to set it up just fine here, but then you're going to set it equal to the radius. It would be set equal to the radius if it was under a giant square root. Because it's not, we set it equal to the radius squared. So a lot of it's just pattern recognition. HK is your center, but notice that it's minus h minus k. So for example, the coordinate of a center of a circle is 5, negative 3. So that would be x minus 5 squared plus, it's always plus between the parentheses, y plus 3 squared. Now, why is that? Because whatever the coordinate on the circle is, x, y, like xy represents all of the points on the circle. And if I'm doing the distance formula with these, I have to subtract the x's, and be x minus 5 squared. And I have to subtract the y's, but y minus negative 3 minus a negative is what makes it plus. So xy represents all of the points on the circle. And if you do the distance formula with that generic point and the center, this is what you would have inside a giant square root. But instead of the giant square root, we set it equal to the distance squared, which is our radius squared. So if our radius length is 6, we would set this equal to 36. Not 12. Remember, squaring something's not doubling something. It's not the same thing. That's a common mistake too. So what you'll recognize as far as pattern recognition is you'll recognize an opposite sign. The opposite sign of the coordinates in here. So a positive 5 versus a negative 5, a negative 3 versus a positive 3, and then your radius squared. So one more quick example here. I see the center is negative 2, 3. So that's going to be x, negative 3, 2, sorry. So x plus 3, so that opposite sign. It's always plus between them, because that's what we do in the distance formula. y minus 2 squared, because a point on the circle xy, I'd have to do x minus negative 3, which is really x plus 3, and y minus 2 squared equals my radius squared. So I have to figure out what the radius is. Now here I can just kind of, I could do distance formula. I could do a little Pythagorean theorem. If I have the picture, I prefer Pythagorean theorem. If I don't have the picture, I do distance. That I see this is 2. I see this is 3. So that's, r squared equals 2 squared plus 3 squared. Whoops, this is squared. R squared equals 4 plus 9. R squared equals 13. And so the radius is the square root of 13, but for the equation, you actually want this. You want the r squared piece, because that's what goes in there, is the radius squared. So you actually don't have to find the radius, you have to find the radius squared. But most people do end up finding the radius and then just kind of going back a step. So here is the equation of this circle. So that's it. It's a lot of just, put the coordinate on the left side in the right places with the opposite signs and understand why. And then, given the radius squared, or find the radius squared, or if you just find r squared. They'll try to trip you up by giving you the diameter instead, things like that. But you know what to do with that, of course, because the radius is half the diameter. All right, guys, so that's the equation of a circle. We'll practice this more in class, and then we're going to do a couple more days of coordinate stuff using this concept. All right, see you.